All right, we are live right now. We are live. All right. There's 1, 2, 3. Let's go. Let's go. I need 2 more pens. 2 more pens back.
Yeah.
Come on, Zed. Wasting my ink.
Whip it in there, Zed.
4. Oh no! Oh. Almost had all 5. 5. This is why we need the second camera, right?
80% there.
I know. Nice job. All right, so here's what we're doing. We're doing a moron day. Before we get to the moron, okay, and that's not you as in moron. It means that we need to do more on the last lesson. Okay, M-O-R-E space O-N. Again, old Miss Fraley used to say that. She's still alive. I see her from time to time. She's a very lovely lady, one of my favorite math teachers. She used to say that, a moron day, and thought it was funny. And I feel like if old Miss Fraley in her good Christian self can say that, then it's okay for me to say it too. You morons. All right, so what we're going to do is we're going to do a warm-up, which really isn't a warm-up. And what you're going to need is a protractor, okay? So we picked these up at Farm and Fleet. These are the professional models. I'm sorry not everybody gets to have one of these. They're really nice. I think we used to have a bunch, but then the point was a little too dangerous, and so they decided to not buy anymore. But here's the thing. This one's beautiful, right? You turn this thing, and it opens and closes. We're not tightening it, like trying to use like pressure to hold the thing together like a lot of the plastic ones are, and that pressure over time degrades the gears. This is a smooth action, and things don't go anywhere because this thing is metal. They're really, really nice. I wish everyone had one. If you want to go get one, this is the model to get, okay? Don't buy some other crap. We're not going to use these a ton, but we will use them a little bit. And it's fun to have these things because you can just draw circles whenever you want, which is super cool. Everybody also has a protractor. Sorry, not a protractor. I call this a protractor. This is a compass. Everybody else needs a protractor. Really, we need a straight edge today. We're not going to use the protractor too much. We might measure an angle if we get creative. But anyway, this is a moron. And again, just for those following along at home, when I say moron, what I mean is more on the last lesson, not moron as in you guys are. Oh, yeah, that's right. Here we go. Sorry, my tape is correct, but I am not. My camera needs to be here. There we go. All right, so there's the deal. So what I want you to do first, take out your protractor and use it as a straight edge. I want you to make your own angle. Remember, an angle is defined as how two rays meet. Okay? It's like a meet cute in a movie. So where they meet, the end point, right? So I'm going to draw any angle you want. You can even draw a straight angle, right? If you really wanted to. This works for any angle. We're going to do a construction. We're going to be bisecting this angle. So I'm going to draw an angle like this. Make sure your angle lines, the two rays, are straight and not curved, okay? So do that. That's step 1. Again, we're going to be bisecting this angle. So we're going to put another ray through here that's going to cut it in half. Nice job, Catherine. All right. That's what we're doing. Oh, wait. Was it Catherine or was it you? How did that end? I don't know. Okay. Yep. All right. Okay. So now what you're going to do is you're going to take the point of your compass and put it on the vertex. Okay. And after you put that on the vertex, you're going to draw an arc. Now make sure that this arc intersects your two rays. Okay, so don't have it like extended so far that it doesn't hit your rays. You want to make something like this, okay? Oops, sorry, I'm trying to draw extra hard. That way the line for the arc shows up. It's really thin, which is good for constructions. You don't want your construction marks to be super thick with 3 C's, right? Okay, so where that arc intersects your rays, put 2 points, right? Should hit it twice, 1 for each ray. Hi, Ray. Now we're going to call this angle something because we're going to talk about it, right? So let's call this angle, use the angle symbol. Remember, the angle symbol sits flat. The bottom part is horizontal, perfectly horizontal, right? Whereas a less than symbol is at an angle. It's kind of annoying. The angle symbol is not at an angle, but the other one is. So we use the angle symbol. Let's call it something. You want to X, Y, Z, A, B, C? What are we going to call them? A, B, C. All right, so A, B, C. Let's do A, B, C. Remember, the middle one has to go on the vertex, so I'm going to call that B just to keep it nice and easy. That way when I call it, I will call it ABC, angle ABC. You need that angle symbol, okay? Got to tell me what figure we're looking at here. Is it a triangle? Is it a circle? Is it a square? It's an angle, okay? So we have angle ABC. You could have put A and C separate, right? You could have switched those and it still would have been true. Another name for it would be CBA. yada, yada, yada. What we're going to do now is bisect this thing. So again, the idea is that there's some ray that exists between these two other rays that cuts that angle in half, perfectly in half, always. And we're not going to measure this angle. If you wanted to, you could. You'd find out you're a god like me. I did 50 exactly without even trying, right? I'm amazing. Okay? And again, how you would measure that is you'd put the circle, see that center point of your protractor? You'd put it on the vertex, and you'd make sure that this line right here is in line with the bottom ray. So there you go. That establishes a 90 degree, which means this is 50. You can read it up that way. It's not 130, right? 130 is if we were measuring an angle from here to here, the long way, the reflex angle, right? This is the angle we're talking about, okay? So 50 is what we want, which means 25 degrees should be the halfway point. But we don't need to measure. The beauty is that this works for any angle, no matter what the measure is, and you don't have to prove it for every single possible measure because there's infinitely many numbers, right? We can prove it just by doing it visually and showing that, look, any angle you give me, I can make it happen, which is useful because then on your diagrams, when you need to prove something a lot more complicated, you can say, look, I need an angle bisector here. There's an angle bisector, so it says me, because you can do it with anything, right? So what we're going to do now is take your compass, pick a setting. Doesn't matter what it is. Doesn't have to be the same as before. I'm going to keep it the same, okay? Make sure that setting is locked in because we're going to use it twice. We don't want that goofed up, okay? So get a compass setting. Put the endpoint on A, and you're going to draw an arc that goes through the front of the angle. So you got to tighten it. That way it stays locked. Some of them suck. If it doesn't suck, if it doesn't lock, borrow someone else's that does, as best you can. Here's one. You can try it. Who wants it?
Toss it.
Danny.
No, don't toss it. There's a pointer on it.
Yeah, but it's not one of these. It was a plastic one. It's a plastic one. YouTube, I swear it was a plastic one. It wasn't one of these.
No, it was completely metal.
All right.
100%.
So put your point on A, draw an arc, and keep that setting. After you have that, you're going to do the same thing for point C. And you'll notice that those arcs should intersect. Remember, these arcs are really circles, right? We're just not drawing the full circle out. Right? We could draw a full circle around C, a full circle around A. And the radius, or the setting that you chose for your compass, will be the same for both those circles, right? So where they intersect, you'll notice, if you put a point there, if you were to connect those 2 points, let's call that point D. If you were to connect those 2 points with your protractor as a straight edge, you'll notice that ray BD that you just drew is an angle bisector. So that means this angle is congruent to this angle without any measurings. And again, mine was exactly 50, which means halfway is 25 because I'm a god. Bam, 25, baby.
I don't believe you.
That's okay. You don't have to believe in me because I believe in you, Danny. That's how God works. All right.
Did you just call yourself God?
Yeah, it's a joke. My history teacher in 8th grade did that once, and I was like, yeah, the only God you are is Buddha. Then he kicked me out of class because he was fat. And then he came out in the hallway after yelling at me, and then went out there and like slammed the door, and he's like, that was funny. Like, I can't let you like get away with that, but that was funny. So I'm gonna pretend to yell at you for a while, and everyone's gonna think you're like in big trouble. You're gonna go back in the classroom with your head down, right? You know, like all sad, and then we're gonna move on. I was like, Mr. Crawley, you're the man. Shout out to Mr. Crawley. All right, so here we are.
Mr. Mac, can we ever get a story time on when you went
Never.
around the tour?
All right, never at all, ever. That's all secret stuff. All right, so what do we know? This is what we know. Let's write it now. Is everybody with me at this point, more or less? Do we understand the process of doing it? Because I want you to try it on your own next.
More or less.
More or less, right? About 50. So what do we know? We know that BD, the ray, right? Hi, Ray. BD is an angle bisector, right? So it bisects, B-I-S-E-C-T-S. What angle does it bisect? Angle what? AC. AC is not an angle. ABC. It's easy as 1, 2, 3. All right, so it bisects the big angle, right? Therefore, what did we learn? I'll give you a hint, writing in red. What do we learn after? If this thing bisects ABC, what does that mean? It's kind of obvious. Yeah. What angles are congruent? Angle what? AB what? ABD. And angle DBC. I'm going to write it CBD just for fun. They're congruent. And I didn't do that just because CBD is fun to say. I did it because notice that how D and D are lined up and B and B are lined up. That's really nice, right? That's really nice when those are lined up. It's easy to tell what points are matched up here, right? They share B, they share B, they share D. A and C are the two different points between the angles. So this angle here is congruent to this angle here, right? By definition. Let's write that. By definition. What definition? Well, the definition of angle bisector, right? We know BD bisects ABC by construction, if you want to write that. Right? We can create an angle bisector for anything. Any angle you want. I want you to try that on your own now. Actually, you know what? Let's go a little bit extra, because I'm all about the extra, right? Do you guys remember how to bisect a segment? It was like one of the first constructions we ever did. Draw your segment however you want. Okay? Call it AB. Now we want to cut the segment in half, right? Now we're not just going to get a bisector here, like we did here. We're going to actually get a perpendicular bisector. What does it mean to be perpendicular? That's parallel. Touchdown, yeah, perpendicular, right? This guy right here hits it at 90 degrees. So we're going to create a line segment that's going to hit this at 90, and it's going to cut it in half. So here's how you do it. Remember, take your compass, put your point on A, and extend your compass more than halfway between A and B. Okay? That's definitely more than half. And then draw an arc, okay, like this, like a half circle. Do the same thing on B, again, keeping the same compass setting. And where those two arcs intersect, we're going to create a line, right? Or at least 2 points that we can connect to a line. Are you with me?
Yeah.
You seeing what I'm doing? Should look familiar. And then when we draw that line segment in, let's call it CD. That gives us a perpendicular bisector, which means it hits it at 90 and cuts this in half. And not only does it cut AB in half, but AB also cuts CD in half. Notice that, let's call that point E, the center point here. Notice that AE and EB are congruent, right? But that does not mean AE and DE are congruent, right? These guys are paired up, these guys are paired up. You could get lucky and have all four be the same, but we don't know that for sure, okay? We do know this hits at 90. We do know that these are bisected. Okay, and the way we would write that is we would write segment AB bisects segment CD. And then we also know that segment CD bisects segment AB. And if you wanted to, you could also write that, hey, it hits it at 90, right? They're both perpendicular bisectors. So here's what I want you to do on your own for your warm-up, okay? I want you to construct one of these, angle bisector, draw any angle you want, bisect it, okay? Again, the way we do that, if you're lost on the directions, we go to B, we pick a setting, doesn't matter what one, okay? We draw our arc, we label those 2 points. Then we go to those points and we pick a setting, we draw an arc. Keep the setting, draw an arc. Where they intersect, angle bisector. So again, 1, 2, 3, 4. Yeah.
Can I just do it on the backside?
Yeah, that's cool. Backside, I would highly encourage you to do it there. Okay. Same thing with the segment bisector. Draw a segment. Go more than half. Draw an arc. Keep the setting. Go to the B. Draw more. Draw an arc. Where they intersect is your perpendicular bisector. So get on that. Song of the day is by Thundercat. Thundercat is a interesting fellow. Plays bass. He's probably the greatest bass player alive. I think that's like just a fact.
I think you are.
Greatest bass player ever. Probably really close. If not, definitely.
What kind of jumps did you play? Wait, our bass.
He is a very large black man with incredibly long dreadlocks, or at least used to, that were all kinds of different colors.
Reggae man.
This is from his 2017 album Drunk, which has amazing album art. He is the sickest bass player. It's like a 12-string bass. I mean, like everything you hear is just him playing bass. It's insane. The song features Michael McDonald and Kenny Loggins. You probably don't know who Michael McDonald is, but Kenny Loggins is the guy who did the Footloose soundtrack. He's like the guy you think of when you think of white soul music. Okay? The song is called Show You the Way. It's featuring both of those guys and Thundercat. Yeah. If you need help, I'll be here to show you the this one, draw a segment, go more than halfway, arc, cross.
Would you just like listen to music by yourself?
Oh, by myself? Well, I try to listen to at least 4 albums, new albums every week. But I've got a lot of playlists.
What kind of music do you listen to?
Like all of it. Yeah, I mean, I majored in it at one point. Despite majoring in it, and despite like doing all the music stuff I've done, I'm actually like really bad at it.
Really?
Like surprisingly bad at music. But I really like it. I'm getting much better at guitar though, because I played so much guitar in this last week. Right now, like almost solely Radiohead, because I'm going through their entire discography and learning how to play everything that Johnny Greenwood ever plays, which somehow brings me closer to God. Johnny Greenwood, man, that guy. Whew, he can do no wrong. Like after I master him, then it's on to David Gilmour, which will never ever happen in my lifetime. But he's the guitarist, like one of the main guitarist from Pink Floyd. Like the grit, just stupid amazing, just stupid good. All right, so we're gonna put this away. Like yeah, dummy thick, right? Like but with a guitar. All right, so again, today's a moron day. What we're gonna do is construct and measure some angles. Done. Checkaroony. We're going to talk about regular polygons. What is a polygon? What is regular? Convex versus concave, and then perimeter and distance. And the way we're going to do that is we're going to talk about the homework, which looks like this. Stop throwing stuff in class. What is wrong with you guys?
Yesterday I threw a great 30% headshot.
Yes, I did. Yes, I did. See, don't you wish we had like an extra camera to capture everything that goes on? Like, this is like a quarter of the show right here. I don't know. It'll be a while before we.
The other teacher probably would have yelled at me or something. Throw me out of class. Oh, do I pass these over?
No, this is all one thing. It's a lot of pages, but it's only 5 problems.
Is this homework?
And we're doing one together. Yeah.
Ooh.
Staple if you want.
Back
Oh my God, this is very big. Guys, it only has 5 problems. Okay, we're gonna do one together.
Smack.
Yeah, go.
A. E.
Here you go.
A. Y. E.
Here you go.
A. Y. Y. E.
Oh, I thought I had class.
Oh yeah, if you like. Oh wait, did we not grade the homework? We didn't grade the homework, did we? No, we did. We did. Good. Okay. Sorry, I must have been doing warm up to that homework. So that is inferior. It's 3rd hour and already everything is running together in my mind. All right. All right, nerds, so check it out. We got some questions to answer. Let's talk about it as we go. So it says write the name of each polygon. So first off, begs the question, what is a polygon? Well, I'll tell you what a polygon isn't. A polygon is not something that looks like this. That's not a polygon. Whoops, you can't see the whole thing. Here you go. Okay? That is not a polygon. And the reason for that is that we have 3 segments here, and they don't connect at their endpoints. See how they connect somewhere not an endpoint? In other words, you can't have things sticking out, right? Doesn't work that way. Also, this is not a polygon because circles don't have sides. So it has to have sides, and it has to connect at the endpoints. That's a polygon in a nutshell, okay? So triangle, polygon, square, polygon, rectangle, polygon, right? The list goes on and on and on. You get it? Polygon, on and on and on. 42069 IQ. All right, so those are what polygons are. Okay? Here are some popular names, okay? Kind of like Becky, right? It's like kind of used to be a popular name, and John, right? Here's some popular names of these gons, okay? Triangle. You probably heard of it. That's the one with 3 sides, right? We have quadrilateral, which includes anything that has 4 sides, right? Triangle, there's only one way to do it. I would. Because it's a moron day, we don't really have notes, so this is kind of your cheater. Really, this is a review of what you should know from like 5th grade, probably. But if you don't, that's fine. So quadrilateral. Quad means 4, right? Pentagon, like the, has 5 sides, also known as Satan's shape. Hexagon, which you think would be more up Satan's alley, right? Hexes and stuff like that, right? Come on. 6. Besides the number, like, yeah, why is hexagon not? Okay. 7 is a septagon, or at least that's what I would call it. A lot of times, if you have something that sounds weird, instead of saying it, you'll just call it a 7-gon or like a 9-gon. Okay? And we'll do that. So we have a 7-gon, which has 7 sides. And then we have the octagon, which is too fun to say. We're not going to say 8-gon, right? 9-gon. 10-gon actually has a name, decagon, you know, like December because it's the 10th month of the year.
That makes 0 sense.
Yep, I know. Think about that one, right? Decagon. And then we have the 11-gon, right? And the last one we'll stop at is the 12-gon, which is a dodecagon. Do meaning 2, dec meaning 10.
I think it's dopagon.
Nope, not dopagon, although dodecagons are the dopagons of the family, in my opinion. I think they're pretty cool.
Oh, I just spelled dopagon.
Oh, no. All right, so those are the different names. So question, which one is that? It's a pentagon, because it got 5 sides. All right, so we named it. Tell whether the polygon is convex or concave. All right, so here's the deal. Convex polygons go inward. So, I'm sorry, let me say it again. Convex is like a contact, concave goes in. So we have concave down here, and we have convex here. You would not want to put a concave contact into your eye. That would be painful. Convex pushes outwards, okay? Another way to think of it is that the internal angle of the shape we're talking about is greater than 180. Do you see how that angle is a reflex angle? Right, so that's going to be something concave. So if I were to complete this and make it an actual polygon, right, that's a concave polygon because it has a reflex angle inside of it. Say internal angles, right? Inside voices, internal voices, right? That's what I hear all the time. They don't go away, and I just do my best not to listen to them, okay? Internal angle is over 180, which means it's concave. This guy, if I were to make these sides instead of a curve, like a dingus, right? Here, this is convex because all of the internal angles are less than 180, right? That's less than 180, 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 okay? Remember, 180 is a straight line, so even though that's bigger than 90, it's still less than 180, okay? That's one way to think of it. So if we look at this, that looks like less than 90, less than 90, less than 180, less than 180, less than 180, less than 180, less than 180. The internal angles are all less than 180, which means this thing is convex, okay? Another way to do it is take out your protractor, which I have given to someone else or misplaced. If you extend these lines, imagine if you extended this, right? Would that line intersect the inside at all? No. How about this one? Would it intersect the inside? How about this one? No, right? That means it must be convex. An example of something that's concave that would have lines that intersect would be on page 3. Notice that if I extended this, wouldn't that go through the inside? Do you see how that would go through the inside of the figure? Right? So that would be an example of concave. And you can tell, right? That angle right here, definitely bigger than 180, right? That's a reflex angle, yo. All right, so we've named it. We've called it convex. Mark congruent segments. So congruent segments are all the same length. So how are we going to figure out the length of these segments? Well, distance formula, right? Now, what is distance formula but the Pythagorean theorem, right? So why plug in a bunch of numbers with points if you can be clever, right? Now is the time to be clever. I can draw a triangle here between these two. That's 4. That's 3. So what's the hypotenuse? 5, right? It's a 3, 4, 5 right triangle. If you don't have that special Pythagorean triple memorized, 3, 4, 5, that's fine. Because 3 squared is 9, 4 squared is 16. Add them together, we get 25. Root it, we get 5. Okay? Same thing here. 1, 2, 3. 1, 2, 3, 4. That means this must be 5. So ED is congruent to BC. So we put little tick marks there, right? Spoilers, this guy and this guy aren't the same, and that guy's not the same. This guy's 4, right? Because you can count the squares. What about this guy? Trying to figure out CD right now. It looks like 1, 2, 3, 4, 5, 6, 7, 8 in vertical distance, or horizontal distance, I should say. 1, 2, 3, 4, 5, 6 in vertical. Oh man, is that a nice right triangle or is it not? It's not one of our 3, 4, 5s, right? Let's find out. 6 squared plus 8 squared, right? And then we root it. What's 6 squared, everybody? 36. What's 8 squared? 64 and 36 makes? Hundo! Root of 100 is 10. So it is a nice one. Turns out, that's just a 3, 4, 5 right triangle, except everything's multiplied by 2. 3 becomes 6, 4 becomes 8, 5 becomes 10. Ha-ha. Ha-ha. So another 3, 4, 5 right triangle would be like a 15, 20, 25 right triangle, right? I multiplied everything by 5. All those would be valid. That's 10, that's 5, that's 5, that's 4. How long is this last side? Let's see. 1, 2, 3, 4, 5 in the, 4 in the horizontal direction. And then it goes down 1, 2, 3, 4, 5, 6 in the vertical. So we have 6 squared, which is 36. 4 squared, which is 16. 36 plus 16, let's do it in our head. 36 plus 10 is 46. 46 plus the remaining 6 is 52. So 52 rooted is going to be this side. Root 52, which sounds like a fun place to drive. So not congruent, not congruent, not congruent. The 5s are, right? use the distance formula to find the lengths. That's what we did. And write the perimeter. So perimeter is just all the sides added up, right? So it's going to be 5 plus 5 plus 10 plus 4 plus root 52. Now, just like in life, all you can do is what you can, right? Can't do any more. So let's add up as much as we can. 5 and 5 makes 10, and 10 makes 20, and 4 makes 24. And then we add on root 52, whatever that is, right? Now, could you plug in root 52 to your calculator? Yeah, and you get a decimal that goes on forever and doesn't repeat. It's an irrational number, which means you'd have to round at some point. And the question is, why round? Just be exact. Right? If we're allowed to round, then we can round anywhere we want. So it doesn't really matter, right? So why not just take the easy thing and just say, yeah, I'd rather not. Take the win. That's the perimeter. Questions, comments, concerns other than for my mental stability? Wonderful. Turn the page. What kind of shape is that? A stop sign. Octagon. It's got 8 sides. Okay? We need to talk about one more thing. Okay? What it means to be regular. This is very important. Okay? Metamucil. Regular. When a figure is regular, or I should say a polygon. When a polygon is regular, it means that all the sides are congruent, which means it is equilateral. You probably heard a triangle called equilateral before. Lateral means side. Equa means equal. Yeah? Wonderful. Fantastic. Great. So equilateral means equal sides, right? That's what lateral means. It also has to be equiangular, which I think you can figure out what that is. Equal angles, right? Now, if you take a gander, those are all equal sides. Spoilers, they are. Here's 3, here's 4. That means that's 5. Here's 5 across. Here's 4, here's 3. That means that's 5. That's 5 up. Here's 4, there's 3, there's 5, right? 5, 3, 4, 5, 5 down, right? They're all going to be congruent. Show me the work behind that if you would. If not, I'm whatever. I know, I'm not doing a very good job of that. I'm being a bad math teacher today. All days. If you measure the angles with your protractor, you'll find out that the angle here, if we extend that out, is going to be bigger than 90 degrees by quite a bit, right? We've got, looks like, if I keep going, I've got this thing upside down, or backwards, that's why. I can't read numbers backwards. Looks about 140 degrees, right, from here to here. If I extend that out, about 140. So that's 140. Now if we check this angle, what are we going to get? Are we going to get 140? Let's check. Looks like, if I extend that out, looks like less than 130, right? So this angle is different than this angle. If you want, you can do 2 little things there. So the angles aren't the same. They're not the same. You know how I can prove that without having to measure? Check this out. Draw a triangle, right? Draw a triangle. So this angle right here, what kind of angle is that? That angle. Nope, try again. Straight angle, right? It's 180. Okay, so whatever this little bit is, plus 140, should get us 180. So that's a 40-degree angle, yeah? Something like that, right? Pretend we didn't know that was 140, but whatever that is, they should add to 180, yeah? Cool. Well, here's the deal. That's 90 because it's the right triangle. This side is 3. This side is 4. Now, the bigger the side, the bigger the angle, right? If I start extending that side out, right, if I stretch that triangle to bigger than 3, notice how the angle would get bigger too, right? So the side with the 3, the opposite angle is going to be smaller than the side with the 4's opposite angle. So these two angles aren't equal. Do we agree? That angle there and that angle there can't be the same because this one opens up to 3 and this one opens up to 4. Well, this angle right here, the angle in question that we're trying to prove congruent to this one, right? This guy right here, that guy's across from the 4, right? But look at this guy. He's across from the 3. So those two angles are different. And if those two angles are different, can these be the same? No, because they have to add up to 180, right? So pretend that one's 30, right? Well, if that's 30, this has to be 150. If that's not 30, can this one be 150? No, right? Just something quick to think about. So those angles are different without me having to measure. I can prove that. We'll prove it formally at some point. Again, this guy right here, convex or concave? Concave. Very good. Count the number of sides. Have fun. Oh, yeah, that guy. Woo, yeah, parallelogram. This monstrosity is connected between B and C. It's just hard to see. Turn the page. Last page. It says, draw an example of a convex regular polygon. Or pentagon, I should say. Okay, pentagon. How many sides? 5 sides. Regular means what? 2 things. Equilateral, which means same sides, and equiangular. Same angles, right? Convex. What does that mean? Doesn't collapse inward, right? All the internal angles, right? They're going to be less than 180. So you have to draw an example. It doesn't have to be to scale. So draw something with 5 sides and label the parts that say, okay, that's equal to each other, right? That's all you got to do. Right? If I wanted to draw a triangle and say it was equilateral, I'd just do this. Right? I wouldn't have to actually measure it. Are those angles actually the same? No, because I drew it freehand, and that's not even a straight line. It's a curve, right? I don't need you to pull out the old protractor and actually bust out a pentagon that's convex and regular. Number 7, can you have a concave triangle? If yes, draw one. If not, conjecture as to why. So you don't need to prove it, but you need to conjecture why that might be impossible if that's not possible. Okay, if it is, then draw me one, right? That's a really easy way to prove something's possible, is to show a possibility, right? Self-development for 2 points. Remember, you need 10 per semester. It's optional, okay? Do it or do not, but you need 10 per semester. It says prove that a polygon cannot be both regular, remember that means equilateral and equiangular, and concave. So both regular and concave. My hint to you, what do you notice about the angle relationships as you go from a convex polygon to a concave polygon? Think about those internal angles. Does the number of sides matter? Meaning that if you can prove it for a quadrilateral, does it work for any type of polygon? The answer to that better be yes, because if not, you have to prove it for every single polygon. And how many polygons are there? Infinitely many, right? Just keep adding sides. So if it works for a quadrilateral, it should work for anything, right? So prove it with a quadrilateral. 2 points. Give you your best shot, okay? Questions on this homework? Nah? Wonderful.
So do we need to find the perimeter on every one of these?
Yeah, you do.
You go.
Like the list.
Yeah. What? Convex and concave. Which one of which? Alright, convex.
Convex. Concave is like a cave.
Yeah, that's.
Cave in, right? You would not want to stick something concave into your eye, right?
I don't think you want to stick anything here.
You might want to stick a contact in your eye because it's convex.
That's it.
Got him.
Got him, coach.
Do it. I don't know. He just said do it.
No. No.
It says you block Mr. Mac from his own.
You banned me from my own channel? Yes, you may. That's it, guys. That's all we're doing today. Remember, star testing tomorrow. Woohoo! The reason for the season, why I became an educator. And then also, review Thursday, test Friday. Keep your protractors and compasses, come by, on your desk for the next class. Like and subscribe. Get your parents to comment. You do. Oh yeah, I finally found a stapler remover, which means I was able to remove the staples from all the tests and quizzes that were A's, and now I can scan them and send them to mom and dad and tell them to buy you ice cream, okay? If you ever got an A in here on any of my quizzes. That means you, Catherine. See you later.